Acids and bases introduction. An alkaline are bases that dissolve in water. Acids are proton acceptors and bases are proton donators. The strongest base starts at group 1, making it the most reactive. So here if you look at the periodic table, group 1 is here. That's why lithium, sodium, and potassium is all in group 1. The OH shows that it's a base. These are the most reactive bases. This theory states that acids ionize in water and that it splits up into its ions. So if you take this, for example, hydrochloric acid, it splits up into its H and Cl, H being the plus and Cl being the negative. Please take note of this. H plus is always acidic. So if you have a look, acids increase the concentration of H plus ions in an aqueous solution. H plus, remember, is acidic. A base increases the concentration of OH minus ions in its aqueous solutions. The Lowry-Bronsted theory can be identified by an acid-base reaction is a proton transfer reaction, in which the proton is transferred from the acid to the base. An acid, a compound from which a proton can be removed, and base, a compound that can remove a proton. Take note of this, H3O plus is always acidic. So if you look at these examples, you have HCl plus H2O. You always need to form this. So you have to add an H to the water to make it acidic. So you have H3O plus Cl minus. If you look at HNO3 plus H2O, you have to always add an H, and then you'll have NO3 minus. This is your radical, so you need to know what charges they have. H2SO4 plus H2O, which will give you H3O plus, because remember you're adding an H, plus SO4 minus. This is monoprotic acid and this is diprotic acid. The last concept that we'll be having a look at today is conjugate acid-base pairs. Conjugate base, always take the H away. Conjugate acid, always add an H. An amphiolite is a substance that acts both as an acid and a base. There are two, HSO4 and H2O. HSO4, when you take the H away, it becomes SO4, and if you add an H, it becomes H2SO4. The water, if you add an H, it'll be H3O, and if you subtract the H, it'll be HO. Basically, OH minus. Here's an example. You see, you have an acid, base, an acid, a base. You need to find a base that corresponds with the acid. So you have hydrochloric acid and Cl minus. This is a base, and in the previous slide we said that H3O plus is acidic. We need to find these pairs. Here is another example. We have an acid, base, because what is a base? Acid H3O plus is always an acid, and a base. You need to pair them up. They correspond. Here's the acid-base pair. Here's the acid-base pair.